Today, in the storage corner of my workshop, I found a broken light bulb. The annoying part is that I bought it only 4 days ago. Recently, the metal workshops near my house have been running day and night. Sometimes the power in my house becomes weak and the lights flicker. That unstable power may be why this bulb failed so early. So today, I will take it down and check it. Maybe something inside can still be reused. First, I need to open the plastic diffuser cover. This cover is usually attached quite tightly to the lamp body. If I force it open, the plastic can crack. So I use a hot air blower to soften the plastic edge first. When the plastic gets warm, the glue and locking edge become easier to separate. This helps me remove the cover more gently and keep the housing for later. After opening the cover, I check the LED section inside. The LED chips still look quite normal. I do not see clear burn marks or cracks, so my first guess may be right. The problem is probably not in the LED board, but in the power circuit underneath. This part is often called an LED driver. First, I remove the LED board. Then I remove the aluminium heatsink underneath so I can reach the power circuit inside the bulb body. And this is the power circuit of the bulb. You can think of it as the main electrical control part. Its job is to convert household AC power into suitable DC power for the LED chips. It also helps the LED current stay more stable. If this circuit fails, good LED chips still cannot light up properly. Just as I expected, this power circuit is burned. The weak and unstable power recently may have damaged it faster. If I repair the bulb normally, I need another power circuit. But before buying a new one, I will search my old parts basket. In DIY, the part you need is sometimes hidden inside something you almost threw away. And here it is. I found an old charger. This type is often used for rechargeable flashlights, emergency lights, or small electronic devices. The outside looks ordinary, but what I need is the power circuit inside. The circuit inside this charger also converts AC input power into DC output power. In principle, it has some similarity to the damaged circuit from the LED bulb. Now I will open the charger and check whether this circuit still works. First, I cut away the old wire that I no longer need. I keep a short section of wire at the output side of the circuit. According to the marking, this output can be around 4.2 to 12 volts. Later, I will use a multimeter to check whether it still works steadily. Next, I connect 2 wires to the input side of the circuit. One wire goes to one input terminal, and the other wire goes to the other input terminal. This input side receives household AC power from 100 to 240 volts. Because this is mains electricity, I must work very carefully. The wires must not touch each other, and I must not touch them when power is applied. At this stage, I am only preparing to test the circuit. I am not installing it into the bulb yet. Weak power is something many homes have experienced, but it should not be ignored. When the voltage drops too low or keeps fluctuating, electrical devices may work incorrectly. Lights can flicker, power circuits can overheat, and motor-based devices like fans, pumps or compressors can run heavily, heat up, and fail faster. So if weak power happens often, it is better not to let devices run too long in that condition. Now I connect this circuit to household power for testing. Then I use a digital multimeter to measure the output side. The goal is to see whether it can still produce stable DC voltage. If there is no output, or if the voltage jumps too much, I cannot use it for the next step. The result is quite good. This power circuit still works and gives about 12 volts DC. However, measuring voltage alone is not enough to prove that it can power every load for a long time. A small power circuit may show the correct voltage with no load, but when it powers a real device, the voltage may drop or the circuit may heat up. So today I will reuse it first for a short test. If the circuit gets too hot, or if the voltage drops too much, I will need a stronger 12 volt power supply with a suitable current rating. Now I install the power circuit inside the bulb housing. Then I solder the two input wires to the lamp base so the circuit can receive power from the original bulb contact. The lamp base is where the bulb normally connects to the socket, so the solder joints here must be strong, neat, and must not short. I check each joint before continuing. If weak power often happens in your home, do not ignore it. When the voltage keeps fluctuating, it is better to turn off devices you do not need, especially high power appliances. For LED lights, refrigerators, pumps, or important electronics, a voltage stabilizer or a UPS can offer better protection. If this happens many times, ask an electrician to check your home wiring. At this point, I could almost reassemble the bulb in the normal repair direction. But wait a second. When I look at the bulb housing, the aluminium heatsink, and the 12 volt power circuit, I get a different idea. Maybe today, I will not just repair this light bulb. Maybe I will turn it into something completely different. First, I need to drill 2 holes in this aluminum heatsink. This heatsink originally helped cool the LED board, but in my new idea, it will become an important mounting frame. I mark the positions and drill slowly so the holes do not shift. Now I have a brushed DC motor. This type of motor is often used in DIY projects that need high rotational speed and good pulling force. I will mount it onto the drilled aluminum heatsink. The motor shaft needs to stay near the center so it will not vibrate too much when spinning. By now, some of you may start to guess my idea. But keep watching, because this light bulb is about to get a very different use. Next, I use 3 small wooden pieces to secure the motor. Each piece fits between the inner edge of the aluminum heatsink and the body of the brushed DC motor. I attach them with hot glue. These wooden pieces are not for decoration. They help hold the motor body firmly and reduce shifting when the motor spins. If the shaft moves away from the center of the heatsink, the device can vibrate strongly and run poorly. With high-speed rotating parts, keeping the shaft centered is very important. What do you think I am trying to make from a broken bulb, an old power circuit, an aluminium heatsink, and this small motor? Can the bulb housing hold this whole mechanism steadily? Now I solder the wires of the brushed DC motor to the power circuit. I solder them to the 12 volt DC output points. This is the power supply for the motor. Before soldering, I check the positive and negative wires to avoid the wrong rotation direction. After soldering, I start reinstalling the bulb housing. I place the wires neatly inside, keeping them away from the motor shaft. Then I use hot glue to make the housing more secure. At this point, the bulb housing is not only covering the circuit, it also helps keep the whole device compact, easier to hold, and more like a finished product. Before testing, I check everything again: the power circuit, motor wires, shaft position, and outer housing. At this point, what do you think? Can this old power circuit handle the mechanism inside? This aluminum heatsink was originally made for an LED bulb, but now it has to hold a high-speed brushed DC motor. Can this thin bulb housing handle the vibration? Or will everything loosen as soon as I apply power? And this is my idea. I plan to turn this broken light bulb into a small fan using a brushed DC motor to create the rotation. It should create airflow to cool my working area. Do you think today's project will run smoothly? Now I install it in the place where I want to use it and start testing. When power is applied, the circuit inside will provide DC voltage to the motor. If everything is centered well, the motor should spin more steadily and create better airflow. Let's see if this broken light bulb can come back to life in a new way. What do you think of this project? From a nearly new but broken light bulb, we tried to turn it into something with a completely different use. If you have a better idea for an old bulb housing, leave a comment below.